Let's take a look at the free response question having to do with first derivative, second derivative, concavity, all that just tied up into one. It's a fairly involved problem. This is from year 2005, so let's take a look at it. It's Form A, I believe. Anyway, let's just first of all notice they give us a chart. This is the function f, its derivative, and its second derivative. And let's read through the problem. It says that it's continuous on the closed interval from 0 to 4. The function is twice differentiable except at x equals 2. So at x equals 2, the first and the second derivative do not exist. Alright, so those are still possible critical points. Let's see, the function has the properties indicated in the table. So anyway, let's take a look at it. So part A says, between 0 and 4, find all the values of x which have a relative extremum. Describe whether it is a maximum or a minimum at each of these values. Okay, so we're going to go look at the first derivative and see where it's equal to 0 or does not exist. Okay, at x equals 0, the first derivative is 4, so that's not a candidate. At x equals 1, that's a candidate. At x equals 2, it does not exist. And at x equals 3, it's negative 3. So our only two candidates are here at 1 and at 2. Alright. So what we need to do is think about it in terms of the sign chart. And we need to look at 1 and 2. Well, luckily we don't have to do any math on this. It's given to us in the chart. So to the left of x equals 1, it's positive, meaning the function is increasing. And between 1 and 2, it's also positive. So it's also increasing. So if it continues to increase and increases again, it is not a relative max. But then let's take a look at the next interval. It does not exist at 2. And then on the right side of 2, it turns out to be negative. So then the function is decreasing. So if the function is increasing, and then it's got some sort of a cusp or something, and then it's decreasing, that means that at 2, it is a relative max. So justifying our answer, we'll say that there is a relative max at x equals 2 because the sign of the derivative at 2 changes from what? Changes from positive to negative. So that should be good justification right there. So we got some points for A just by being able to read the table and to interpret it. Alright? Part B says on the axis provided, sketch the graph of the function that has these characteristics. Well, the first thing we could do is we can focus in on the values and just get a point. So at 0 we have a point at negative 1, and then at 1 it is 0. At 2 it's equal to 2, and then at 3 it goes back to 0, and then it continues to be negative after that. So these are some points right here, and what we need to do is take a look at in between the function value is very positive 4, the derivative is a positive 4, so it's increasing, and then it goes over to 0 right here when I get to what? X equals 1. So increasing. Let's go take a look at the second derivative. The second derivative equals negative 2 at that value, and it's negative right here, so that tells me this graph is concave down. So perhaps it looks something like this, concave down. Okay? And let's look at the next little segment. So we're all the way to 1. So after 1, in between 1 and 2, it's positive and positive. So this positive for the second derivative tells me that it's concave up. So it's doing something like this. Well, then it tells us at 2 that the derivative does not exist, and then it switches to negative, right? The derivative switches to negative, so it's going to do what? It's going to decrease, but what about the second derivative? It's concave down. So it's going to be some sort of sharp cusp, and then we're switching back over to concave down. Alright, perhaps that's not the best looking graph in the world, but I think you get the point. Alright, so just continuing, on the right hand side, it's negative, means it's below the axis, it's decreasing, and it looks like it switches concavity again. So perhaps let me clean this up just a little bit. Concave down, and then it switches concavity and becomes concave up. So something like that should probably get you through. Okay? Let's pause it right here and we'll pick up C and D on the next part.